Hi, this is a build video for an Eggtimer Classic flight computer. This is one of the cheapest flight computers on the market, and it's not Eggtimer's cheapest, but it's probably their simplest to build. And it also is their cheapest and simplest fully functional programmable computer that you can program with a computer. It's all through hole parts, so that makes it a little easier, but it is lengthy build, lots of parts, well over 30 of them. I'm going to treat this as a beginner video tutorial for this, so there'll probably be a lot of explanations that experienced builders may not want to sit through. There's a lot of similar looking resistors in this kit, so make sure you identify them very clearly and know what you're doing before you build. And this one has a little bit more complicated setup because you have to use a computer, and you might need some multiple batteries and some kind of computing device to program it, but we'll go through that. This is my setup. It's a Hakko FM203 soldering station. Now you don't need anything like this. This is all through hole parts in this setup, in this build. So you need, at a minimum, a standard soldering pencil. Weller makes a great 30-watt version these days for less than 20 bucks on Amazon. I'll put a link below for that. You're going to need some good soldering wire. I'm linking to a 3/4 ounce package of Capacitor 6737 inch soldering wire below. That's the stuff that normally comes with Eggtimer kits, and it's really excellent. So you don't have to buy a whole lot of it. That's a good kit to start with. If you're going to upgrade to a soldering station, that's not bad. You can get them for less than 50 bucks these days on Amazon, and they allow you to adjust the temperature and the and the tips. I'll link one below. I don't use that one, but it's up to you if you want to try those. They're really excellent. Once you get your kit out, open it up and lay everything out for inventory. And we're definitely wanting to inventory everything here and actually, physically check it off on the checklist. Because like I said, a lot of these resistors look identical except for the bands. So you want to identify them and know which part is which before you start the build itself. So once you lay everything out, take your checklist, the actual paper that comes with it. We're doing the Rev D version here, and we'll go through each part in detail so you know what they look like. This is the circuit board, the PCB. This is what you're going to solder everything to. Next up, you've got an Atmel chip. This is the processing chip, and that's on one side of the foam. It's that kind of big long chip, and then there's two chips on the other side of it. Those are the Optoisolators. They're 8 pins each. Then you have a couple transistors, these large looking devices with 3 pins each and a metal backing. You get a couple LEDs. In my kit I got a red one and a clear one. It says you may get an amber one, but that's what you get. A voltage regulator. You may need this in the build. You're gonna have to make a decision based on your battery. This is a buzzer, a simple 2-pin buzzer. This is what the ceramic Resonator looks like. It's in my case, blue. Now you get some resistors here and start identifying them. This is the 820 ohm one, and this is white, red, brown stripes on it. Next up, you're going to have a single 1K resistor, and that's with brown, black, and red stripe on them. Next up, you'll have 4 2.2K resistors. And these are a little bit simpler. The bands on them are red, red, red. Next, you've got a single 3.9K resistor, which has stripes that are orange, white, and red. And then you have 4 4.7K resistors with stripes that are yellow, purple, and red. And then finally, you have 6 10K resistors with stripes that are brown, black, and orange. And that's the rest of the resistors. Next up, we have these capacitors. These are 0.1 UF capacitors, ceramic. There's 4 of them. This is a ceramic capacitor, a multi-layer ceramic capacitor. Note it's got a gray section with a black notch on it. That's important to note for when we orient it on the board. This is a push-button switch. This is a 6-pin header, and then I use a pan of ice for holding the board while I solder things onto. You can tape it to the work surface if you'd like, but so I have a silicone mat. That mat is good for all soldering as well. It won't burn or scorch. I use a pair of flat tweezers and a pair of pointy tweezers to move the components around on the board. So if you have a vise, mount it up with the face up, and now we're going to put this Atmel processor on. Note there's a notch on the end, and you have to line that up with that notch silk screened on the board. If you put the chip in backwards, it will not work, so make sure you have it oriented properly. And then gently squeeze the pins together. They're going to be a little bit wider than the holes on the board. Once and be careful not to bend them too far. They can break and you can ruin the chip, but gently push them together. Then I like to use a pair of tweezers to get them, that last nudge in. And then once the board is in, it should look like that, flat to the board, but not all the way down touching the board. There's kind of a notch there on each pin, and everything should be pushed to that. Once you get to that point, you're going to heat up one of the pins on one of the corners, and then apply your solder wire to the other side. You want to draw the solder towards the heat. So do the opposite two pins, and then turn your board over, check it. Just double check really quick, make sure that everything's aligned properly. It's all the way seated flat. Double check the orientation. That notch is where it's supposed to be before you solder everything else and have to desolder things. Now I'm going to speed up the video here because each pin is exactly the same as the other. You don't want to sit here for quite a while watching this. But you notice I just missed a pin. I did go back later and do that pin. You won't see it in the video. But I realized it and fixed that after I finished the board. So I did do that middle pin. That wasn't missed on purpose. But go ahead and solder all the pins in. You should have a nice little tent of solder around the pin, and it should be shiny. If it's not shiny, it's because it's a cold solder and you have to redo it. These are the optoisolators. Once again, you got to match the notch up. There's a small notch at the end of the chip with the notch in the silk screen, and you're going to have to do the same thing. Kind of push the pins together and then get it lined up in the holes. Same thing here. Now these are a little bit looser, so I taped them down. Use paper tape, masking tape, not Scotch tape or duct tape or anything like that. Anything that would leave a residue. But the technique here is exactly the same. Heat up the pin, solder the pin, and have a nice little tent of solder around the pin. We will continue to speed up the video here once we show these things because all the through-hole soldering should be pretty much identical across the board. Now these are the 0.1 UF ceramic capacitors. Now on the board they are marked 0.1 UF. In the instructions it says that they're marked 104. On my board they were not. They were marked 0.1 UF. So make sure that you are choosing the correct spaces for them on the board, and then tape them in. You can see where they are, on the board, and this is what it looks like after I tape them all in. Once you're done with that, you just flip the board over, and you're going to solder every single one of those wires to the board. Same as the other pins, though. You're going to have a nice little tent of solder. It should be shiny, and it shouldn't bridge over to any of the other wires or sections on the board. I'm doing this in real time so that you can see where the pins are if you're following along with your own board. But when we do the resistors, we will speed up the video because they are all the same. Now once you've finished soldering, you're going to clip these wires down to the board. Make sure you're holding them with something like a pair of tweezers like I'm doing here, or a pair of pliers, something, because those little pieces of metal do go flying, and they can get in your eye, they can get caught on the board somewhere. So make sure that you are controlling those when you cut them off and they don't go flying somewhere. And don't throw them out. Those wires, as we'll see here, the cutoff wires for all of these right here, they make great bridge wires, and you're going to always need bridge wires for all sorts of things on these boards as you're building out. So hold on to all of these cutoffs and put them away. Next thing up is the push button switch. You just push it right in the holes there where it marks on the board, and that's the way it should look. You don't want to squeeze that thing all the way down to the board and bend those pins out. It should be cut off the board by about 1/8 of an inch or so, and the pins should be just through the bottom of the board. But there is enough tension. You shouldn't probably have to tape it down. So just turn the board over and solder those 2 pins in. Nothing to trim off here. Next up is the LEDs. Now the LEDs are polarized, so make sure the longer pin it's not that much longer, but I'm pointing to the longer pin. Those go in the positive side, the plus side. So make sure, once again, you get the polarity right and look at that longer pin on the LEDs and match it up to the plus side on the board. But once you've figured that out, you just drop them in the hole. They are very loose, so I would tape them down. And once they're nice and secure, taped in, turn the board over. Once again, solder the pins and trim the excess. We are speeding up the video here now because there's all of the rest of the soldering for the through holes are pretty much similar. Now at this point, we're going to start installing the resistors after this. We're going to the instructions ask you to start with the 1K resistor. Now we're going to start with a 2.2K resistor and a 10K resistor because the point on the board where these go, it's very tight, and I'll show you that. But the way you do this is you take the resistor and you bend back one of the pins about 180 degrees. I like to use my tweezers, my flat tweezers for that, and that's what it should look like when it's right. Now the convention is that you put the resistor facing out away from the board with the top color band up so you can tell what it is later on. You put the resistor in, you tape it in, and then solder the pins and clip them off. Now I did that 2.2K resistor first because it's right up against the LEDs. That's not the order that the instructions say, and I apologize for throwing you a little bit of a curveball here, but I prefer to do it this way because it just makes it a lot tighter when you go to try to solder in the way the instructions go, which is the 1K, then the 2.2K, then the 10K in that little block right there. And that 10K is just kind of sandwiched in there. So I'm going to do this 2.2K, and then I'm actually going to put a 10K in with the brown, black, and orange bands. Show you again the technique I use for bending it back. Just bend it right at the top of the resistor itself. In this case, the brown band would go on top, and I'm going to put that in that 10K spot. Once again, this is not in the order of the directions. After this, we will go back to the order of the directions, but I put that 10K in so I avoid it being in that tight spot between the 2.2K and the 1K resistor. If you follow the instruction order, it won't be an issue, and I encourage you to try it. I just found in the past that it makes it harder to get that 10K in after the 1K and the 2.2K are in place. But now we're kind of back on track here in the order of the instructions, and I'm going to stop showing how to bend them. I'm just going to show them as we go now. This is the single 1K goes into that spot. Bend it, face out. The brown band, and this one should be on top. Next are all the 2.2Ks. I'm going to put them all into the board and point them out. So that's 1, 2, 3 right there. There are 4 of them total. There's the one we put in. There's 1, 2, 3, and 4 is the one we put in originally. So it's already in there. So tape those all down, solder them all in place, and clip them. Sometimes like that right there, it's easier to clip some if they're in your way. Next, we've got a 3.9K resistor, and that goes right on the other, right by the chip, and then next to that ceramic capacitor, with the orange, white, red bands, and the orange band is up. Then we have 4 of these 4.7Ks. Now here is a very important thing to pay attention to. The 4.7Ks are oriented against the length, on the short side of the board, not the long side. So this is the correct orientation for those two. It's very simple to put them in the wrong place and orient them the wrong way. So be careful. I've done that in the past and couldn't figure out why the board wasn't working because I put those 4.7K resistors in the wrong holes. So make sure they're in the right orientation and in the correct holes, and then solder them in. and then we'll move on to the other 4.7Ks. The other two go right there and right there. And tape those in, solder them in, and you are good. Okay, once you've got these 4.7Ks installed and clipped, the next thing up are all of these 10Ks. Now we already put one in, that first one, and the rest of them go, and where I'm pointing out now, all around the board. There's 6 of them total. So put them all in place, and then tape them in, and then turn the board over and solder them all securely. This is what it looks like when they're all taped in and ready to go. Okay, so now we're just going to solder those in and clip all the leads. And we are almost done with these resistors. The last two are these 820 ohm resistors that go right on the other side of those optoisolators. So bend those, put those in place, tape them in, and solder our resistors. Okay, we are done with those resistors. Now we've got this electrolytic capacitor right here, and it goes in that spot. Now that square in that gray section needs to face away from the processor. So that should be to the outside of the board. That's really the key thing here, is making sure you're orienting it properly. It'll probably fry your board if you have it the wrong way. So go ahead and solder those in and clip the pins for that. Next, we're going to put these 6-pin angle header in. The short pins go into the board, the long pins go out. I like to tape it down by just putting the tape right through the pins. It makes it easy to stick it to the board. Once you do that, go ahead and flip the board over and solder those pins in. Give it a decent amount of solder here. It's big pad and large pins, but if you're going to be pulling the terminal plugs from the wires on and off on this, it puts a little bit of stress. So make sure you got a good chunk of solder in there. This is the buzzer. It's not polarized, so you can put the 2 pins in either way you want, but just put it in flat to the board and tape it down. It's very loose, so you definitely want to tape this down. But once you have it securely in place, flip the board over, solder the 2 pins, and trim those flat. The next component up is the 3-pin ceramic resonator. You put it in the 3 holes marked XTAL and then tape it down. And then just flip the board over, and you're going to solder the 3 pins securely. Nothing to trim here. Now I want you to notice on this first pin how dull gray that solder tent is. Clearly that's a cold solder. So I went back really quick, heated it up, just touch it a little bit, and there you go. Nice shiny tint. That's the way you want it. Now, the voltage regulator option. If you're going to use a small battery for this, for the logic of the board, under 4 volts, you don't need the voltage regulator. I personally like to use 2S LiPos, which are 7.4 volts. So I want to use the voltage regulator. So you need to bend the middle pin out. So the holes on the board are in a triangle. So you need to make the pins into a little tripod here. So bend it out, bend the middle pin out about 90 degrees, and then bend it back 90 degrees towards the board, so that you end up with this kind of tripod of pins underneath the voltage regulator. And once you do this, it should fit pretty easily into the 3 holes on the board, which are located right next to the buzzer. So just go ahead and drop it into the holes. The middle one goes towards the back, towards the push button there. Tape it down, and then you solder all 3 pins in. So, in this question about which batteries you should use, I personally like the 2S LiPos for the logic, because they last a long time. You can put them at the beginning of a launch day, and it'll pretty much power the board all day. but you're going to need some other batteries as well to power the deployment channels. We'll talk about that later. But for now, that option is also going to require some bridge wires. So here we go. We take some of those wires we had from our cutoffs here, and to make a bridge wire, just take your tweezers and bend it over into a kind of a clip. And then in this case, we need to put it into the two 9-volt slots. There's one right on the edge of the board, and then one in between the voltage regulator and the push button. So put 2 bridge wires in there and tape those down with small pieces of tape, and then solder those bridge wires in on the other side of the board and trim the wires. Now, do not put a bridge wire in the 3-volt section if you're going to use the voltage regulator and a larger battery. If you're only going to use smaller batteries, then you would only put the bridge wire into the 3-volt holes and no voltage regulator. Okay, so once you get the 2 bridge wires soldered in, trim the wires off. And the next components we're going to install are these large transistors. They fit into these 3 holes near the optoisolators on the other side of the 820 ohm resistors, and that large metal plate goes towards the optoisolators and the buzzer and the chip, so they go away from the edge of the board. Put them in. You just drop them in. They're going to stand off the top of the board a lot, so they're very high. Tape them down, and then solder the pins onto those large pads in the back of the board. You do want a slightly decent chunk of solder here. It's a little tougher to solder these, get that pin heated up, and solder everything in. But these are some pretty big components, and they do stand pretty tall off the board. So there's a lot of kind of torque in them. There is an option to bend the pins down and put them on the bottom. I find that the installations I do that's not a very good way for the way I usually install them into a AV bay board, because I like to use screws and standoffs that use those large holes on the corners of the board, and they get in the way. So it's up to you. It is an option in the instructions. I personally find it easier in the builds that I do with these classics to just keep them tall on the top, but solder them in and trim off all the pins. Now I'm using some terminal blocks here. They don't come with it. These are ones I added. I doubt that they are recommended by Eggtimer, but they fit fine. You can find these on Amazon or get them from Eggtimer. So I'm choosing to put some terminal blocks in for my deployment channels and batteries. It just makes it a lot easier to take them on and off, especially when you're testing, but also in your installations. But make sure the large holes that the wires go in are facing out towards the end of the board. Put them on, solder them in, and then you're good to go if you're going to use terminal blocks. But you would have to add these as an addition. Now I'm going to have to add some kind of logic battery cable. And once again, since I'm using 2S LiPos, I'm going to put a JST connector onto the holes marked B. Just make sure your polarity is correct. I'm using some helping hands to hold the wires in. And then you solder your battery cables right to the thing. I'm going to use some 22 gauge wire here as some switch wire. Right next to the battery holes is a switch, or 2 switch holes. So for now, I'm just going to install 2 wires, and they're not going to be connected to anything, into those holes. Later, I will connect these wires to a switch on the rocket itself to turn the computer on and off. Now, once we get those in, the entire installation is functionally done. We do need to test it. So I put some extra battery cables into the terminal blocks for the deployment channels, because you need batteries to test the deployment. I use 2 Christmas lights on the deployment channels themselves. That'll simulate putting in an igniter into those, and then I twisted the switch wires together to simulate the switch being turned on. I'm going to use this 2S LiPo as a test battery, and then we're also going to need another LiPo as a deployment channel test battery. So we will connect these up, job right, and everything went well in the build. We should get a series of beeps. And that's good. Now, we also note that I've connected the terminal cable, the USB terminal cable, and I've set it up in my computer. I use PuTTY as a terminal emulator. I won't go through that piece. You can find that in the instructions. But if you've done all of the build correctly and you've connected it to your computer correctly, you should get a screen that looks like this in your terminal emulator. And that says, yep, we've actually done it. And now you could use that to program it. Now, I'm also going to test the deployment channels. And in order to do that, you hold down the push button while you connect your battery, and you'll get the light turn on. And then on your computer, I'm not showing it, but you'll get you'll get a MON prompt. In this case, we're going to check the main channel. So I'm going to press M on the computer, and that's going to cause the computer to beep. That means we know it's ready. And when I press the button, it should light. That's testing that the deployment channel, the main deployment channel, works. Now we're going to test the backup channel. Same way, press the button, connect the battery. The light is on. I've pressed B on the computer now. And now we know the backup channel is set up. We hit the button and the backup channel light should go on, simulating an ignition and a deployment on that channel. So that's it. It's a successful build. It's not a quick build. I would definitely give yourself some time. Set aside all of your components. Set up your workstation, especially if you're doing this for the first time. Have a good space to work. Make sure it's ventilated. And I didn't go over this in the soldering station setup, but you have to have some kind of vent fan or do this in a ventilated space where you're not breathing in those fumes. Wear a mask. Wear eye protection for splatter. And if you have any questions about this build, it is a beginner build, but this is how it all goes together. Put them in the comments below and I will respond. So good luck, and I hope the build goes well for you.